Okay, good afternoon, everybody, and welcome back to 6170. If you have a laptop open, I would very much appreciate it if you'd close it. I have discovered that it is impossible to learn with a laptop open. It immediately mutates your brain in some magic way, rendering you incapable of listening. Don't worry, I've had the same experience myself. So here's the plan for today. I want to run over request forgery because we got some interesting feedback from students over the weekend, and one of the senses we got is that people wanted a little bit more help for the security assignment, which you're working on now. So I'm going to do a very quick run-through of request forgery, and then we're going to talk about the main new exciting topic for today, which is abstract data design. One thing I want to say about this security work is you might be wondering, I know at least one of you is wondering, because one of you made this comment in the survey that we sent out. You might be wondering, why don't we lead you through in lecture all the things that you actually need to do in Node to fix a security vulnerability? And I'll tell you the answer to that. It's that we try very hard in this course to not use lecture time on things that will not be valuable in 3 months' time. And the problem is the details of the things that you need to know for actually patching a security vulnerability in Node are basically just the details of whatever package you're going to use. And those packages are listed on the assignment. And unfortunately, it's just a skill you need to develop, of basically looking at an API and figuring out what you need to do. If you're finding it intimidating, well, I can assure you that in all these cases, these packages are pretty well designed, and the actual mitigations are very small. So you only have to write a couple of lines of code, maybe at most 10 or 20 lines of code, to actually eliminate the security vulnerability. But what's really hard, I think, is understanding what these vulnerabilities are. Because if you don't really understand what an injection attack is and how it can happen, then you certainly won't know how to fix it. Okay? So that's what we're focusing on in lecture. And that's what I'm hoping you'll get out of this explanation today of what request forgery is. Now, I should also say that one of the problems with talking about security attacks is that there are so many different names that people use for different kinds of attacks. And if you look at the OWASP list, you'll see that they use a bunch of names, and they actually rely on an open source project, which has produced a whole catalog of names. And these names can be very bewildering. So what I've done is I've bunched together a whole bunch of attacks under the class of what I call request forgery, which is a sort of conceptual class of attacks. And that isn't, completely standard terminology. But I'm hoping you'll see that these all fit together. So here's how they fit together. As I explained last time, one of the big problems of building a web app is that you really want to build a program that goes through some sequence of steps, right? That's what the client is trying to do on the right. It's trying to go through some sequence of steps, maybe even cyclically. On the left. But on the right, you've got a server, and because the server is designed to be able to deal with millions of clients, some of whom might just disappear, it doesn't want to be in the middle of doing anything with any client. So the server is typically written in a stateless fashion that just gets a request and handles the request, picking up whatever context it needs to handle that request. And this creates all kinds of problems, right? As you've discovered in writing web applications, it makes them pretty tricky in many ways. But it also produces some particular security vulnerabilities. And those vulnerabilities are, first of all, that the client might execute the commands out of order. Remember, the client is untrusted, so you as the designer of the web app assumed the client was going to do some things in some order, and the client chooses not to, just to spite you. Another possibility is that you send stuff to the client, and the client modifies it and sends it back in a form you didn't expect. And the third possibility is that the command doesn't actually come from the client at all. It comes indirectly from the client. Sorry, it comes directly from the client, but indirectly, it originated in some other place with some other server. So we're going to see examples of all these things, and I'm going to call these all request forgery attacks. And we'll sort of start from the simplest and get a little bit more complicated. So imagine that there's your browser and you're talking to a server, and imagine that you're redeeming a coupon. Okay? So here's a typical pattern used in many REST applications, which is that you basically request a form. Okay? And then what you do is you actually enter the values in the form when the form comes back. Now, in this case, there's a very questionable piece of design. When you request the form in this case, you provide as a query parameter the coupon code that you want to redeem. And what the server does, it says, yep, that coupon code has not been redeemed yet. And here's the form for the details. Just give me your name and address and whatever. And you provide the name and address, okay? And now the web server doesn't need to do any further checks, right? Because it did the check before it sent you the form. And so now everything's okay. Well, is everything okay? Is this a good design? Why is this not? Tell me your name again. Megan.
Because you can just keep providing coupon codes.
Yeah, you can keep doing it again, right? In fact, if I just pretend that I got that form and resubmit that post request, right, then it won't check it, and I can get it to redeem it again, maybe to me or maybe someone else, okay? So that's the first kind of attack. That's called a replay attack. And I've given you an example which is so simple. You might say, well, you couldn't make a mistake that stupid, could you? But people who design web applications make these mistakes all the time, normally in more subtle ways. But this is a classic example of what goes wrong when you rely on a context that you shouldn't be relying on. Here's another very simple example. You're in a cafe, for example, and you log into your bank account, and here's Evil Eve, and Evil Eve simply snoops on your wireless connection and logs in with the same credentials, okay? Your host. And that is called a man-in-the-middle attack, okay? Of course, this is normally mitigated by using a TLS connection or something like that. But again, you always have to ask the question, what if somebody is listening to all my communications? Here's another example. You log into your bank, and the bank does some kind of server-side checks. We're assuming that your password and username have been provided, and sends back a welcome message along with some kind of credential, a cookie, saying that you are now logged in, okay? So this is the way all sort of banking sites work. And now what happens is, let's say you say, I want to move some money between accounts. So you submit the request to get a form, and you get a form back, and it says, well, okay, you want to move money to your account, to your main account, say, which account do you want it to move from? And it lists your different accounts, assuming that you're going to choose one of those, okay? And you could do that, but, and then it will do no further checks, because it knows it's you, right? Well, what if you did this instead? What if you said, move it from an account you never mentioned, right? So I choose Arvin's account at that point. So what goes wrong here? Yeah, the server's doing no checks at all, right? The server is relying on context. It's saying, the designer of this web app said, well, like I sent you a form with the options, right? Why did you send me back something that wasn't any of the options? Well, the answer was because you're a clever programmer, and you knew that you could just make up a request, that you didn't need to actually use that HTML at all. You could just submit a request directly. So this goes by the fancy name of a direct object reference attack. Right? What it means is that you managed to access that object directly, namely this bank account, and there was no access control check on that. Okay? What's the obvious remedy for this attack? What should the web app actually do? Yes? Tell us your name. Michael. Exactly. You should check that it was one of the options, or at the very least one of your accounts. Good. Here's another possibility. You want to do a transfer, and it asks you what account you want to transfer to. So that's where I am legitimately going to enter Arvin's account number, for example, because I owe him some money because he bought me dinner last night. So I'm going to send it to his account. And now, let's suppose again that there isn't a check at the other end, but I did this on a public machine with the session still open. Why is that problematic? Yes? Exactly. What's your name? Billy, right. So as Billy points out, someone else can come in, right? And they can just pick their own account to transfer to. So that is called a request forgery attack, because this new request has essentially been forged out of the blue. Okay, finally, now we're getting to the one that is the one that you probably will have a little bit more difficulty in understanding, which works like this. Suppose that I go to my favorite social media app, friendy.com, okay, and I read a post, and it comes back with a script. And that script says, transfer all my money to Arvin's account. Okay? Now, why might that command work? Well, that command might work because I previously logged into my bank account, and I previously got a credential in the form of a cookie from my bank account. So my browser is primed to be ready with full authentication to do this action, okay? So this, of course, is highly problematic because there's no amount of checking, right, after this, when this request is received, that will ensure that every request will be stopped that wasn't actually desired. Because maybe it's moving money between my accounts, which I should be allowed to do when I'm logged in, right? But maybe I didn't want to move money between my accounts. So this is highly problematic. How does this happen? Well, it happens, of course, because an evil person goes and puts that script on friendly.com. And this is called a cross-site request forgery attack. And it's cross-site because the attack is mounted on friendly.com, but it causes a request to another site, namely my bank, okay? And in this case, it's actually been combined with a cross-site scripting attack, right? The way that I actually got the request, the way that the evil attacker got the request to the browser was by inserting a script into the post that then got executed when the post was read. Yes, Megan? You do not need a cross-site scripting attack. For example, you can simply get someone to visit an evil site. So for example, if I can entice you to visit my site, right, which runs all kinds of evil scripts, then I don't need to mount a cross-site script attack on that because I don't need to mount that attack because I own that site. So all I need to do is get you to a place in which you'll execute that command. I could also, for example, simply give you a URL and an email. And that URL, you click on it, and that executes that might execute a request that you weren't expecting. That's a great question. So it doesn't need to be combined with cross-site scripting. Okay, any questions about this? Yes? Tell me your name again. Costa. Okay, good question. So, right, sure. So, so you see, you're showing yourself, Costa, to be a very modern kind of guy, because in the old days, the way websites used to work was, that you would go to the website and it would refresh the entire page by sending you back a form that you would then enter values into, and then those values would then be submitted subsequently when you click submit with a form request, right? Now, you guys have learned how to write in this more modern idiom using things like Vue and reactive frameworks, in which maybe there's never any refreshing of the page, right? Maybe you just have one page, and all you're doing is submitting requests from that page. But exactly the same vulnerability applies, which is that the requests that come from that page might often use data and context which is sitting in the browser, right? And that context had to come from somewhere, and of course the place it came from is the server, right? So the server populated that page with what requests are allowed and what parameters might be issued, right? And the point is that that's a perfectly valid thing to do so long as you remember that the client is untrusted and the client can always meddle with that, okay? So does that answer your question? Great. Yes. Is there any way to ensure that the user has that cookie? Well, this, when the transfer actually goes through, when the transfer request is received, the server will check that that cookie was provided with it. I actually should have shown that that cookie actually gets sent with the request spontaneously. Because that cookie is associated with the domain name bank.com, it will be submitted on every request to bank.com. And that's exactly the danger. The danger is that the cookies are sent spontaneously. And so if I can get a request to be executed in your browser and you have the cookie there, it will be sent whether you like it or not. Yes? What's your name? Julian. Is there a way to find out who has a cookie? But it wouldn't help, you see, because you wouldn't be able to distinguish the legitimate requests from the illegitimate ones. Well, let me tell you, in fact, there is a way, and that's what I'm about to tell you, okay? So hold on for a minute and come back to me if this isn't clear. So I want to just very briefly tell you what the remedies are. So first of all, these are things I mentioned last time. How do you deal with man-in-the-middle attacks and snooping? Well, you use something like TLS, right? If you turn on an encrypted connection, then you can't actually listen in on the conversation. If you're worried about the client tampering with the cookies, right, which is one possibility that I didn't show, but it's in the same genre of the attacks I showed you, then you can basically encrypt the cookies so that they can't be meddled with. And this code, this is not interesting code, I'm just showing it to you to remind you that what you typically have to do is you have to install some framework, in this case, the node cookie, the express cookie parser, and it will do that for you. We talked about cross-site scripting and injection attacks, and the basic idea of those is get rid of the code. And the way you get rid of the code is you either use a template mechanism, which automatically sanitizes whenever you use those double curlies, for example, in any template language, whether it's Vue or whether it's one of the templating languages that's just server-side. They all provide this kind of sanitization. Or in order to fight an injection attack, you can use this prepared statement mechanism, which looks like it's simply inserting a string, you see. It says, make this query and inject the parameter name where the question mark is. But by doing it in this form and by passing the parameter separately to the query command of the API gets to look at that name parameter and check that it hasn't got SQL code in it. Okay? So that's what we talked about last time. And then finally, this was the tricky one. How do you protect against cross-site request forgery? And the way you do it is, as Julian was sort of hinting, you have to have some way of distinguishing a good request from a bad request. And one way to do that is you figure out whether or not you actually sent a form. Because remember, in that case with the post on Friendly, I wasn't actually looking at a form on my bank's website that I was filling in to do a transfer. It just did the transfer in the background, completely invisibly. So one way to solve this problem is that when you deliver a form to the client, you put a hidden token in with the form. That hidden token says, yes, any request that comes now is a legitimate response to this form. And then the form request simply sends that token back again, and the web server has to check that that token was the one that was sent out previously. Okay? So it's a very simple mechanism. It's kind of annoying to have to implement, and that's why there are packages like the CSurf middleware for Node, and this is just an example of the code you have to write, a few lines of code to set that up, to basically make sure that those form tokens are actually generated properly. And you have to put the form tokens into your form so they get sent back. So that's a slightly annoying piece of work. This is the trickiest thing you'll have to do in your problem set. It's the only one that requires more than 2 or 3 lines of code, really. Because you're going to have to take these form tokens and make sure that wherever you have a submission, you put the form tokens in there. And then there were various things that I talked about last time that I don't want to take time on now. And you can look over these in the lecture notes, but they're things like keeping sessions short, making sure you authenticate well, considering things like, when you get to the point where the user says, I now want to transfer $1 million to Arvind, right? Ask the question, are you sure? Could you please convince me that you really are Daniel Jackson and that you really do want to take $1 million out of his account? Like, make me enter, my password again, right? Make me enter a captcha to show that I'm not that I'm not just some script that's running. Okay. And then finally, always think about these contextual assumptions you're making and don't make them, in short. Instead, in the server, check every request in full. So whenever you do something like this or something analogous to it, where you're sending some options to the client, right, make sure that what you get back is what you expected. Okay, so that is all that I plan to say about cross-site request forgery. And that sort of ends our discussion of security. I want to get on to the exciting topic of abstract data models, which we're going to talk about for the rest of the day. So now we're transitioning in the course from basically learning all this technology. You've been learning this amazingly huge and complex array of frameworks for building web applications, and I know it's been a formidable amount of work. You will be delighted to hear that with this week's assignment, you will have finished your last coding assignment, and the next few assignments are higher-level design assignments. I can't promise that they'll be easy. I think they're still challenging and exciting, but you won't have to write any code. But when we designed this course, we asked ourselves the question, what are the big things you need to know to be able to design web applications really well? What are the things that go beyond coding? Because let's face it, you're MIT students, so you're going to be amongst the best coders in the world. But coding does not survive a whole career, typically, right? You've got to be able to do something bigger than coding, right? And the people who really end up having influence and impact in an organization are typically the ones who can influence things more at the design level. So what do you need to be able to do at the design level? So we're going to teach you 3 things in particular. One, today and on Wednesday is how to think about the data in your system in an abstract way without getting mired in details. Because it turns out that basically the data determines everything. If you get the data right, everything else follows. That's thing number one. Thing number two is understanding the concepts, which is basically what kinds of patterns of behavior are you going to design into your system? And that's going to be the following week. And then we're going to consider usability. And we're going to focus on the idea of heuristic evaluation, which is basically a posh way of saying all the things we've learned about user interfaces for the last 20 or 30 or 40 years condensed into some simple rules. And that lecture will basically be a précis, a lightning summary of what you would have learned if you'd taken 6813, which was the old usability course. Okay? So the purpose of this particular lecture is to explain to you why data models are useful and potent things, what a data model is, what it means, and how to construct it. And the key ideas are these. First, separation of concerns, because the really valuable thing about a data model is not so much what you say, but what you don't say. The idea of modeling an abstract structure, and the idea that a data model is really just an invariant. Okay, so here's the basic explanation of sort of where this whole field came from. The classic origins of data modeling are in what's called domain modeling. When you called a company or a consultant to build you a big database, right, obviously before they got to the schema, they needed to know what kinds of things would go in the schema. So imagine if you called someone to build WebSys for you, right, that person or that team would need to know things like, well, what is a semester? What's a class? What's a student? Because if you didn't know those things, you clearly couldn't design this database, right? And they would need answers to all kinds of questions, like, can a class last more than one semester? You know, can a student register for overlapping classes? You know, two classes that happen at the same time. The answer is yes, unfortunately. Can a student register for multiple semesters in one go, right? You can imagine that these are a big deal, because if these things are possible, then your data structure is going to have to be much richer. And before you even get to designing those data structures, you'll need to know these things are possible. Now, one of the problems of explaining data modeling in this modern age is that people look at this and they say, well, this is so boring. I'm not going to build, registration systems, for universities. I'm going to do cool, exciting apps, right? And those cool, exciting apps don't need data models. Well, they do. And so the other kind of application, which I think is probably going to be more relevant to most of you, is what you do when you need to model a new structure. So you're building a completely new app, and these structures might not exist out there in the world. You're going to invent them for yourself. But you want to get these structures straight in your mind before you actually think about how you're going to represent them. So here's an app that I think is kind of a cute app. I don't know if anyone's used this. It's called RunP. And it has a delightful tagline, because movie theaters don't have pause buttons. So what this app does is you load up this app, you tell it what movie you're watching, and it tells you when you can go to the bathroom, because they basically pre-programmed it with all the most boring scenes. And they tell you, wait until Owen says to Claire, I have a cabin to finish. And at that point, make your dash, because, it's really, you don't need to be there for that. Has anyone used this app? No, I didn't expect it was the most popular. But I think this is a really cool idea. But just imagine, if you were going to design this app, right, what would you first do? What would you ask yourself? What kind of questions might you have about what kind of data was going to be stored? What do you think? Excellent. So how are we going to even represent this interval? Is it going to be a start time and an end time? Are we going to break the movie into 5-minute segments? Exactly. That's the most fundamental question. Excellent. What else? Exactly. What kind of rating are you going to put on them? Beautiful. What else? Whoa, now we're getting to really profound questions. That's right. So you're going to need to think about things like that. But that actually raises an interesting question. Maybe you're going to rank or prioritize the segments, right? So you're not going to tell people these are safe peeing times. But you're going to say, if you do have to pee, then this is your best bet. This is your least bad option. So that's right. So the point is that there are just all kinds of questions, And another thing I thought of is, you could label them with scene type. You could say, maybe you're the kind of person, I hate violence in movies, particularly things to do with dentists, like Marathon Man. I have complete dental phobia. So I don't want to be there when there's a dental torture scene. I want to be 100 miles away, right? So I would appreciate knowing, horrible violent scene, someone being cut up into pieces. That, for me, would be a very good time to take a break. For other people, it might be conversation. I don't want to hear conversation. I only want to see action, right? So, so there are all kinds of things you could do. OK, so that said, I've tried to motivate for you what the reason is that you might want to construct a data model. But I know you don't believe me, right? Because people are always skeptical about anything that requires writing a single line that isn't code, right, seems to be gratuitous work. I know that. And so you're thinking, I still don't buy it, right? Cute story, but I just don't buy it. He's pulling my leg. So here's what we're going to do, and this is an experiment for the first time ever in 6170. I'm going to get you to construct your own data model, writing as little as you think you can get away with before I've told you how I think it should be done, OK? So here's the exercise. I want you to imagine that you're building our old friend, the URL shortener, OK? And so here's what you're going to have in it. You're going to have permanent shortcuts that are owned by users. So you're going to need to remember which user owns which shortcut. And you're also going to have a notion of expiring shortcuts, right, which are going to expire on a particular date, say, that are not owned by anyone. And what I want you to do is design the data content. What data is stored, not how it's stored. And you can use any notation you like. Now, this is not like a very clever design exercise. We're going to do this for just a couple of minutes. So the issue here isn't getting the perfect design. It's just sketching something, right? So whenever you do any kind of app, you're going to need to do this kind of thing. So I want you to do this. And you can do it. You can write a little bit of code. You can write a few sentences. You can draw a little diagram and take a picture of it with your phone. You can draw it on your screen and take a screenshot of it. But that's what I want you to do for the next 5 minutes, OK? And then we're going to discuss what you came up with. OK, who thinks that they've done enough of this to sort of get the spirit of it and would like to stop? Who would like a few more minutes? It's always interesting when the union of the two are a very small number. So I don't know what the rest of you are thinking. Should we talk about it? Raise your hand if you want to talk about it. All right, cool. So let's see, first of all, just some interesting things. So I got the impression that most of you wrote text. How many of you wrote text while drawing a diagram? How many of you drew diagrams? Well, OK, Megan did. Who else did? Wow, you're the only one. OK. Oh, Billy did. Did you draw a diagram? OK. So for those of you who wrote text, how many of you might have drawn a diagram if it wasn't such a pain in the neck to read it in? Yeah, there you go. So I'll have something to say about that later. That's interesting. How many of you feel that what you wrote down was pretty good and would have sufficed for something you were building? I don't mean that you completed it. I don't mean that at all. I don't mean that it was a perfect artifact. I mean that you're on the right path. This is the kind of thing you would do, and this would work. How many of you felt that? All right, I'd say most of you. Good. So it's my job now to convince you that that is not the case. OK? So, and that you have something to learn about doing data models. So I'd like you to consider the following question. So this is a sort of self-grading step, OK? You don't need to put this into the form, but we're going to discuss this. So the first big question is, what does your model actually say? Whatever you wrote down, does it address the most fundamental question? So here are a whole bunch of questions. And does it address the question of whether or not two users can share the same shortcut? Whether you can have two shortcuts for one URL? Whether you're allowed to have a permanent shortcut with no owner? Whether you can have a shortcut that is both expiring and permanent? Does your description allow that? Or was that sort of implicit? Does it allow the possibility that the target of a shortcut could be changed? Right? Did you think about whether or not it was mutable or immutable? So think about this for a minute. So how many of you think that you missed some of these things? So pretty much all of you. Do you think that those things could be significant? So I would argue they could be significant, particularly these things to do with how many of one thing. Because how many of one thing, right, is going to determine whether or not you need typically an array or a set or something like that, or just a single slot. It's also going to determine how you do your queries. And if you're going to try and enforce exactly one or at most one, you're going to have to do uniqueness checks. So these things can actually generate quite a lot of work. The other question I have for you, did your model include coding details? Did any of you, for example, use an array or something that was really a coding decision and nothing to do with thinking about the data? Or did any of you have like a database table with an ID in it? Anyone want to confess to doing anything like that? Yeah, a couple of you, right? So of course you did that because you're used to using a programming language as a way of explaining something, right? And you're technical whizzes, so it makes sense to you. But I hope you can see the danger in this, which is that if I'm trying to just get at the data, I don't yet want to put into the data any decisions about how I'm going to represent it. And that's that's a fundamental thing, and it's called separation of concerns that we'll talk about in a minute. I'd also like to ask you this question. How easy do you think your description would be to modify or extend? Let's suppose I wanted to make the expiring shortcuts owned as well. How many of you, looking at what you wrote down, would say that would be an easy thing to do, a trivially easy thing to do? How many would say, well, it's not trivially easy? Okay, a couple. So some on each side. How about having shortcuts owned by accounts with multiple users? How big a change is that? A bigger change? That's a common request of people, use shortcut services, right? Maybe like the 6170 staff would like to share shortcuts together. So these are all the considerations. So what's really going on is that we're trying to separate what the data is from how to represent it. And what data models give us is a tool for thinking about this, for thinking one concern at a time, separating the concern of what the data is from how to represent it. And here's the paradox of it. The paradox of it is that if you want to do a really good job of representation, if you want to have a really well-optimized structure that performs really well, then paradoxically you've got to avoid thinking about it. Because you've got to figure out exactly what data you need first, leaving open as many possibilities as possible, right, for how you could represent it. Because every time you make a decision unknowingly, you're actually sort of limiting the range of things that you might choose. Okay? It will also turn out that when you do this and you think just about the data, you actually get all kinds of surprises, as we'll see, that there are much more subtle things going on that you might not have guessed. And then finally, if you can separate these concerns, then what this means often in industry is you can have different people doing these things. You can have like a database designer who knows all about designing database queries and indexes, do the schema design, and you can have someone who's better at doing the front-end design, do the first part. And this idea of separation of concerns is probably the biggest idea in programming. This is just one instance of it. Does anyone know where the term separation of concerns was actually coined, where it comes from? It sounds like such a standard term, doesn't it? Anyone want to guess? How old do you think the term is? A year old? 100 years? 20 years? How old? 40, yeah. So Megan guessed 40. I think you'll be about right. So actually, it was invented by Edgar Dijkstra. I didn't put the date there, but he has these wonderful missives that he sent out, actually through a fax machine. He hand-wrote them in his handwriting, sent them out to all his friends, and then they sent them to other people. And you can go and find these online, and they're great little essays. This one doesn't illustrate it, but they have all kinds of wonderful little anecdotes and sometimes very sharp comments in them. So they're quite entertaining reading. If you want to read, for example, what he says about software engineers, you will be very entertained. I'll give you a clue. He doesn't approve of them. Oh, I have to give you one example, don't I? So one of my favorite comments is he was once asked, tell us, Professor Dijkstra, what kind of computer do you use? And his response was, I don't use a computer. He said, are doctors required to suffer from the diseases that they seek to cure? So that was a typical Dijkstraism, which now seems a little quaint and old-fashioned, but he was a seminal guy in the field and introduced all kinds of very important ideas in programming language design and verification. And he coined this term separation of concerns, which he claimed is the only effective way to do thinking, basically. He said the only way you make progress thinking about stuff is to think about one thing at a time, right? And so that's what we're really trying to do with data models. The other reason that data models are really important is that data is sort of central to everything. It's almost like the data in a system is like an orbit, right? It doesn't exactly describe the behavior, because you don't know how the thing will move around the orbit, but it tells you what the orbit is. It tells you where it can go. And it's not just databases that you can design with data models. Any kind of transient structure can be defined. OK, so what we're looking for is a lightweight notation that's easy to learn, that's more succinct than code, and more precise than sketches, and is hopefully representation independent, which means that it says nothing about how you actually implement the data structure. What we're actually going to do is we're going to talk on Wednesday about taking a model and systematically turning it into an implementation. OK, so now I'm going to tell you about the syntax. So if you can close your laptops, because I'm going to tax your brains by doing this at a fast and furious pace to keep you on your toes, OK? So, so the syntax of this data modeling language is actually incredibly simple. There are just a very few things you have to learn. Actually, can we give the TAs the... Oh, great. Can the TAs hand those forms? So we have a cheat sheet that we're going to give you. All the notation fits easily onto one sheet of paper. And I'm going to just explain the notation to you. But here's a warning. The warning is that this is very simple, but like a lot of simple notations, actually learning how to use it is a little bit tricky. So the example I'm going to use is an email app. So imagine that you want to design an app like Apple's email app, or Gmail or whatever, and you basically want to design this structure of messages and folders and so on. OK? So how are you going to do that? So what we're going to do is we're going to think about the elements that are going to be in this email app, and we're going to organize them into a structure. Not a structure in terms of its implementation, but just a structure for what we know needs to be there, right? So the first step is classification. There was a time when one of my favorite things was collecting Japanese stationery. And every time I had an opportunity to go to Japan, I used to buy all these cool bits of stationery. And they had all these things which also sounded very good and very funny in English. So this was one that I picked up when I think I was already like teaching software engineering classes. This was a long time ago. But they had this little purse that said, "Do you good. It will do you good to classify." Of course, what they meant was classifying your recycling. But I like the idea. So let's start by classifying. So the first thing you do is you classify the things that are out there. What kinds of things do you think are in this email client that we're going to need to put in the structure? What do you think? Contacts. OK, cool. Yes, I hadn't actually thought of that. That gets into another whole area of functionality, but great. And in fact, the relationship between contacts and email messages is quite sad in Apple Mail. Yes, credentials. OK, you're getting very clever. Yes, absolutely. If you want to do things like public key infrastructure-based signatures and so on, sure. I'm thinking more basic things. Yes, Megan? The trash. Good. So, so here are some things I came up with. Messages, addresses, and folders. The trash is an example of a folder, right? Now, here's the first idea. These boxes are just sets of things, nothing else. So don't think class. Don't think anything fancy, OK? This is just a set of things, unstructured things. So we have a set of messages, a set of addresses, and a set of folders. The next thing we do is we specialize them. We consider each of these, and we say, is this thing divided? Can it be usefully divided into some smaller subsets? So let's take folders, for example. Could you imagine classifying folders into some subclassifications? What kind of folders might you have? What do you think? Yes, Jackson? Oh, you could have local and remote folders. That's exactly right. That's a very tricky one. Good. That will have to go in next year's lecture. What else? A simpler classification. Yes? What's your name? Say it again? Essian. Yes, you can have things like your inbox and outbox. So what I'm actually going to divide it into is the user-defined ones and the predefined ones, right? So the predefined ones are the things like the outbox, and then the user-defined ones are the ones like work and play and so on, okay? So this little symbol means that a folder is either user-defined or predefined, okay? It essentially says it's broken into these subsets. And then I can break into more subsets. So I might say the predefined ones are inboxes, the sent box, the trash box, and so on, okay? And these little slashes there mean that the classification is sort of for good. It means that once you're in one of these categories, you can't move to another one, right? Now, this is, by the way, one of those ideas that seems incredibly pedantic and ridiculous when you first encounter this notation. You say, oh, come on, you know, I really need to figure this out. But think about it. If there is a box that at one point, a mailbox or a folder, that is at one point the trash, and at another point, you know, my vacation folder, right? You can imagine I'm going to have some pretty hairy functionality to support those kinds of transitions, right? And those kinds of things actually in email clients go very badly wrong. I can tell you they go badly wrong in Apple Mail. So they're very tricky. Note also that these things here, although they're sets, we're assuming there's only one. I'm assuming there's only one of each. There's only one inbox. I haven't bothered to say that. Maybe there could be multiple inboxes. If you actually have multiple accounts, then you will typically have multiple inboxes. And then finally, notice that I wrote that name italicized. The implication of that means that the subsets exhaust it. So it means that every folder is either user-defined or predefined. There isn't another kind of folder. But notice that I didn't do the same for the predefined folders because maybe there are some other ones, like notes or something, okay? So you might say, well, how could one of these classifications not be immutable? Well, here's an example of one that isn't immutable. Maybe I want to classify messages into read and unread messages, right? Well, I don't need to introduce the read ones because they're just by definition the ones that aren't unread, okay? And so in this case, I haven't put one of those little markings on, and it's not italicized, so it says there are some messages that are not unread, okay? And there's no immutability because obviously a message can be unread at one moment and then read at another. Okay, who's with me so far? All right, great. So that's everything you need to know about sets. There's one other thing you need to know about this notation, and that's the relationships between them. So now I start looking at these sets, and I start asking, how are they connected to each other? So if I pick, for example, messages and addresses, well, obviously a message can be from an address. What other relationship might I have? To, exactly. So I can add that as well. And then I can ask myself, are these relationships immutable? In other words, if a message is from an address at one point in time, could it be from a different address at another point in time? What do you think? No. That would be an unnecessary complication. What about a message being to an address at some point and not to a different address at another point? Could I allow that? So it's interesting. So Megan says no, and Kassam says yes. Okay, so why do you say yes? Really interesting. You could have a message and send it to one person at one time and another person at another time. If you did that and you claimed that that was the same message, right, that would be introducing a very interesting richness into this email client that most email clients don't have, right? The idea that these multiple instances are sort of instances of the same message. I don't know where that would go in a design, but it's an intriguing idea, right? It's sort of more like the idea of what these emailing services call a campaign, right? Where you send out a whole flood of messages that are all essentially instances of the same message. And that's a very interesting idea. It's not an idea that's present in an email client like Apple Mail, right? There, every message just gets the set of 2 addresses, and that's it for good. Okay? But what I hope you're beginning to see is that there are a lot of subtleties here. So I can put actually these markings on both ends. When I put it on that end, it says the address associated with a message through from or to doesn't change. Now here's a more interesting kind of relation. Let's suppose I want to put messages inside folders. So now I have a relationship that the contents of a folder is some messages. And I could also say that the content could be folders. Okay? Now this would be a little bit confusing if I did this, because you see I have 2 different relations that essentially mean the same thing. So the way that this is handled in data modeling is like this. What you do is you don't do that. Instead, you do this. So what I've done here is I've introduced a new set, a set that I've just called objects. And objects are divided into folders and messages. And a folder has some contents which are objects. But since an object can be a folder or a message, this allows a folder to contain a folder that contains a folder that contains a message, and so on. Okay? Notice that this is subtly different from the classifications I did before, because this notion of object didn't exist. If I say to you, what's in an email client, you're not going to say, well, objects, right? We introduced this as a conscious generalization. And this generalization is the kind of thing you do in software design to make the design more uniform. And it has very profound consequences for the uniformity of the user experience. Okay? So that's a generalization that's introduced in this case to unify these relations. So now we have relations. The last thing we need is to talk about how many things there are. So how many from addresses does an email message have? One. But of course, it can have many to addresses. So what I can do is I can mark that by using this exclamation mark to say exactly one, and this plus to mean at least one. Okay? So that's what those things mean. And then likewise, I can do this here. What do you think this says? That question mark means at most one. So what is the interpretation of that marking there? Yes, what is the meaning of the question mark? Costa. So the question mark means at most one. And so what I'm telling you is that these markings tell you, when they're put on one end of a relation, how many things at that end are related to one thing at the other end. So can you interpret what this question mark is going to mean in the context of this little model? What does this tell us about the folder structure? Darius? No, it actually allows you to have two objects in a folder because the objects that are in the folder are at the contents end, at the other end. Right? So if I put the question mark at the other end of the arrow, it would mean exactly what you suggested. Exactly. An object cannot be in multiple folders. Right? So here's an example of a tiny little annotation to the diagram with massive consequences. Right? This means essentially that the folder structure is tree-like, right, or many little trees. What's that in contrast to? Can you think of an email classification scheme that is not tree-like, that allows you to have multiple classifications for a message? Yes, Jackson? Exactly. If you're tagging email, so the label scheme of Gmail does not have this property, right? In fact, the designers of Gmail made it look like folders because it turns out people understand folders much more easily. So if you look at Gmail, you'll see it has move to label. The reason they did move to label was because they found adding a label was too confusing for most people. But the reason for having labels is that labels aren't like this. So you can have, I can mark a message as both, in the folder, with the label 6170, and exciting. I could have a collection of exciting messages and a collection of 6170 messages. And I can have messages that are in both. But in Apple Mail, I have to choose, right? So when I'm looking at my message, I have to say, is this in 6170 or is this exciting? And sadly, I have to put it in one or the other. OK. So putting it all together, there is a model. That is a data model. And the final thing that you do is that the language isn't, this diagrammatic language isn't fully expressive. And so there are some things you just can't say in the diagram. And so what you do with those is you just add some textual constraints. Now, there are nice languages to allow you to do that logically, but you don't need to use those. You can just write down in English words. Can you think of any things that you might want to add that we never mentioned about this structure? So if all the things we've talked about in the structure of these messages and these folders, is there anything that we want to ensure doesn't happen that isn't ruled out by this diagram so far? Oh, excellent, thank you. So Michael points out this particular data model is expressed in a very abstract way. And what you will typically need to do when you actually move towards an implementation is specify the detailed representations of the individual objects. And we'll be doing that on Wednesday. That's a great observation. I wasn't expecting that, Michael, but that's very helpful. Thank you. But I'm simply asking, at the level of these abstract objects, are there relationships or constraints that haven't been caught? being able to forward reply, well, you see, that message would just be to a bunch of people. It wouldn't maintain the relationship to the other message. That's true. So if you wanted to remember which message was in reply to another message, you'd need to augment the structure. Exactly. So that's the kind of thing I'm thinking of. So Michael and Megan were talking about more things you might want to express, and indeed there are such things. What Jackson has pointed out is that even within the bounds of what this expresses, it allows some things that are bad. So this allows the possibility that your trash is inside your inbox. There's nothing to stop that. And so to do that, you add textual constraints. So they might be things like, as I mentioned, we didn't say how many inboxes there are. You might want to say there's one of them, or there's one trash. The predefined folders shouldn't be contained by or contain others. That's an example. Jackson was giving an example of that, right? But you presumably, don't want to put the sent folder inside the trash, and then both of them inside the inbox. You probably don't want to put unread messages in the sent folder. I believe Apple Mail lets you do that, but that's kind of confusing. And we also, although we've said that this content structure doesn't allow you to have two parents, we haven't said that it's not cyclic, right? Maybe, A is inside B and B is inside A. That would be pretty bad if you could do that, right? So, in summary, what we've seen is that you can specify sets, that one set's a subset of another, that basically the little immutability marking to say that the classification is permanent, once an A, always an A. We can divide things into subsets. So this says that A1 and A2 are subsets of B, and no A1 is an A2. They're disjoint. By putting the B in italics, that says that B is exhausted by A1 and A2s. There are no other Bs. And then we've seen the idea of a relation. This relation mathematically is just a set of pairs. There's just a bunch of pairs from A to B. This says that over time, each A is mapped by R to the same Bs. That says R maps the same A's to a given B. Then we have these multiplicity markings. That says R maps each A to n Bs and m A's to each B, and those are the symbols you can use. And star means 0 or more, but normally you just omit it if you don't want to, because that's not a constraint at all. And then finally, I want to point out, you can just write two relation names on the same edge if they have all the same properties. That's as if you wrote two different relations. And that's used when they have the same properties. OK, so who feels like you have a reasonable idea of this notation? OK, so now I want you to try again. So I want you to construct a data model for the URL shortener that has permanent and expiring shortcuts. The permanent ones should be owned by accounts, and users can share accounts, OK? So a little more interesting than the last one. So what you're aiming for here is, I don't know, a model with 5 or 6 nodes on it and 5 or 6 edges, something like that. So this is tiny, but probably a little tricky if you haven't done this before, OK? And if you have a drawing app and are confident with it, then pull it out and do it. Otherwise, probably the easiest way to do it is just pull out a pencil and paper and take a snap with your phone and upload it to the form from there, OK? So we'll do that for 5 minutes. You know what? I'm going to let you do that at the end, if you don't mind, because I want to make sure that I have time to tell you about a few other things. So here's a sample solution. So I've classified shortcuts into the 2 types. I've said that an account owns permanent shortcuts. Shortcuts expand to URLs, and expiring ones expire on dates. Anyone have anything very different from this, or any questions about it? Anything surprising? Good. So that was Michael's point earlier, right? Which is that ultimately you're going to need some way to actually represent these things. And indeed, we'll talk about that on Wednesday. So another one would be, for example, your user probably needs a username, right? And so what we're doing at this level of very abstract modeling, and it's one of the ways we get away with very small diagrams, is we've postponed the question of how you're actually going to represent a shortcut. We're assuming it's going to be a string or something like that, but we don't need to worry about that at that point. But it's a good point. Yes? What's your name? Michael. Every account should be owned by at least one user. Yes, that's a good point. Thank you. Because otherwise that means that you allow a user to delete herself, say, from an account, leaving the account stranded. Beautiful. So that's a really nice thing, right? So Michael has found would actually be quite a serious problem. If I didn't do that check, I've sort of got a garbage collection problem, right? That I've got accounts that could become sort of accounts that could become unreachable. Very nice. Any other thoughts about this? I think what I was probably imagining was that accounts would have their own credentials, but it would be simpler if they didn't. And so I think your criticism would still apply, Michael. Yes?
Should the date be immutable? Because we can imagine like a use case where people want to like, oh, I want to move the experiment.
Yeah, great point. Should the date be immutable? So I would say probably yes, right? Probably should say if you want to extend your shortcut, maybe you should create a new one. And the other thing, remember, is since it doesn't have an owner, how do you get back to it, right? Because if you won't want someone to be able to change the expiration on someone else's shortcut. So what I hope you're picking up is that these supposedly small distinctions actually have some quite major consequences for the design. Okay, so now what I'd like to do is, so you've sketched this model, but you've really done it just by sort of on the seat of your pants based on the sort of vague, informal description that I gave before. Now I'd like to say a little bit more about what the semantics of these diagrams actually is. So the basic idea is that one of these models represents a set of instances. So in the same way that if I gave you a mathematical comprehension like this, right? The set of all pairs x and y, such that x and y are natural numbers and their sum is 4, right? That refers to a particular concrete set of pairs, right? Now, I don't want to enumerate all those pairs typically, because maybe there are a million of them. That's why I use set comprehensions. Well, in the same way, I don't want to enumerate all the possible instances, all the different states my system might get into, so I'm giving you one model. And that model represents all those possible states. So let's look at one of these states as an example. You know, we've got here in orange, we've got folders. In blue, we've got messages. And then in green, we've got addresses. So this says, for example, that the inbox contains message M0, which is from address A0. Okay? So there's an instance. So to understand the semantics, you need to be able to answer questions like this. Is this particular instance in this model? So here's the game we're going to play. I've got one. I'm going to keep the model the same. The model is the model we had. And I want you to look at the instance and tell me whether it's a good or a bad instance. Okay? And a clue. These are all bad. Well, actually, are they all bad? No, they're not. That's a good one. That's a satisfying instance. But all the ones I'm now going to show you are bad. Okay? So how about this one? What's wrong with this? You have messages that are in no folder. Yeah, you do. And that's actually really interesting because, in fact, does my model allow that? Yes. The model actually allows that. The model probably shouldn't allow that. And so, yeah, that would be a good thing to add to the model, that you can't have top-level messages, as it were. But in fact, the model allows it. That's a lovely observation. Yes, Costa? How does it allow it? Well, if you look at the little structure that represents the contents, you'll see it says that every object has at most one folder that it belongs to. The reason I didn't say exactly one folder is because obviously at the top there are objects like the inbox which don't have parents. So I didn't want to say that every object has a folder that contains it, because that would go on forever, right? There have to be these folders at the top. So I actually might need a textual constraint that says the messages, at least, will need to be in folders. Okay? Yes, Darius? A message contains a message. That's exactly right. And what does that violate? Yeah, only a folder can contain things, right there. Okay? So that's a problem, essentially relating the wrong kinds of things. Someone else want to say something up there? You're going to say something great. Okay, here's another one for you. What about that one? Yes, and I've forgotten your name already.
Oh, Adrian?
Okay.
There's two folders containing the same message, which violates the folder and object.
Exactly. M1 is in both sent and trash. And so that, what does that violate, Adrian?
Oh, folder and message object.
There, right?
Yep.
It violates the multiplicity at that end. Okay, there's a multiplicity violation. How about this one? What's wrong with that? Yes, Emily. Exactly. Message 0 doesn't have a from address, so where is that? What's that violating in the diagram? Exactly, that one there, right? So that's another multiplicity violation. How about this one? Yes, Darius. Exactly, and I realize now I actually wrote these constraints in a little logical language called Alloy, which I'll mention on Wednesday. So that was impressive that you weren't thrown by that. But indeed, the third constraint there that says there's no intersection between the set of unread messages and the contents of the sent folder. Okay, so in other words, you can't be both in the sent folder and unread. That's right. So that is a violation of one of my textual constraints. So that's basically the idea of the semantics, that every one of these constraints that's either implicit in the diagram or written textually rules out some set of instances. There's one thing I'd like to point out that's a nice feature of this notation, which is that it's what you might call monotonic, meaning that everything you add to the diagram rules out more possibilities. So I can start by just saying, as I did in fact in this presentation, that messages are from addresses, right? And that tells us that the from relation is a set of pairs mapping messages to addresses. And now if I put in a multiplicity marking like that, it says, now I'm telling you that there's exactly one from for each message. So it's ruling out the relations that aren't functions. And now if I put the mutability marking on, that says that for any message, the set of addresses that it's from is unchanging. So this is actually a useful feature of a diagrammatic notation because it means that you can sort of build things up and that you don't undermine what you've done already. You don't allow new possibilities by adding new stuff. Okay, so I have one more little exercise for you, but we only have 3 minutes left, and so I think what I'll do is, instead, is I'll take questions. So I'm happy to take questions about the utility of the notation, about anything you'd like to ask. We'll have more time to discuss this with some more intricate examples on Wednesday, and also translating to schemas. But if you have any questions right now, this would be a good point to ask them. So this is a very good question. So generally, actually, you're actually forced to do one rather than another. So maybe I'll give you an example of this. You might, if you're building a social media network, may I say I have some users, right? And some of the users are friends. Is that an example of what you mean by an adjective? So this says there are users and there are friends, and every friend is a user, okay? Now, in this case, this would not be correct. And the reason it would not be correct is that we cannot classify the world of Facebook users into those that are friends and those that are not friends. Friends is fundamentally relational, right? Maybe, you know, maybe I'm Arvin's friend, but Darius doesn't want to be my friend, right? He rejects all my friend invitations, right? So friend is not an adjectival notion, it's a relational notion. So that's the fundamental thing you have to ask. Now, sometimes it's convenient to actually introduce an adjective to just support a relation, right? So I might, for example, if I have, let's see, if I have a set of, you know, shortcuts, and I didn't have, you know, expiring and permanent, and I had, you know, an owns relationship to user like this, right? And I said that only some shortcuts are owned, so I can't put very strong multiplicity constraints on this. Every shortcut is owned by at most one user, right? Then a quite useful transformation that often gives you some leverage in how you design your data is to introduce an adjective. So I could introduce the adjective for owned shortcuts like that, and now I can say that every owned shortcut is owned by exactly one user. So that's often a useful thing to do, to sort of introduce that terminology. But as you can see, I've got both the adjectival part and the relational part. And the adjectival part there is sort of optional. Any other questions? Yeah, that's a really interesting question. I think that you're right. Data models get very big. So, for example, people do what they call enterprise modeling, where they'll build a model of the entire enterprise, everything that you need to know, inside IBM's databases. And these get very complicated. And I would say, people don't typically have very good abstraction mechanisms. It's really a research topic. What people will typically do is divide the data model into different domains, and where you sort of try and have sort of minimum cuts between them. But there aren't straightforward ways of sort of grouping all the things in a data model into one box. That would be nice. So if you have ideas there, you could become rich and famous. Other questions? Adrian? So Adrian's question is a very intricate one. His question is, well, what if a malicious script went and got the form? The short answer is, a malicious script generally can't get a form because there's a policy called the same origin policy, which requires that any data read by a web page comes from the same origin. Now, very complicatedly and bizarrely, this policy allows you to write to a website, but not to read from a website. It turns out that that's actually essential for the web to work. This is such a confusing and complicated matter that I've actually included a slide called Same Origin Policy that explains exactly this question that Adrian asked, but I didn't want to introduce it because it's rather complicated and you probably don't need to understand it for the purpose of this course. But if you want to review that, it's in the lecture notes and I'm happy to discuss it with you. Okay, thank you all. See you on Wednesday.